The National Electrical Code, or NEC, specifies requirements for the installation of electrical components, including the proper positioning of the ground lug on duplex receptacles. According to Section 406.6 of the NEC, the ground lug on duplex receptacles is required to be located on the strap, also known as the yoke, that is closest to the center of the receptacle. This requirement ensures that the grounding wire is not bent at an excessive angle during installation. The reasoning behind this requirement is to prevent potential damage to the grounding conductor. When the ground lug is positioned closer to the center of the receptacle, the grounding wire can be connected with a smoother, less stress bend. This reduces the risk of the wire being pinched, punctured, or otherwise damaged, which could compromise the integrity of the grounding path. Section 406.6b of the NEC further emphasizes the importance of proper grounding wire installation by stating that the equipment grounding terminal should be oriented in a manner that prevents the grounding wire from being pinched, punctured, or damaged by the terminal screws or other surfaces. This requirement reinforces the need for careful attention to detail when connecting the grounding wire to the receptacle. The purpose of the grounding system is to provide a low-impedance path for fault current to return to the source, thereby facilitating the operation of overcurrent protective devices such as circuit breakers or fuses. A properly installed grounding system helps to minimize the risk of electrical shock and fire hazards. When the grounding wire is damaged or improperly connected, the effectiveness of the grounding system can be compromised. This can increase the risk of electrical shock and delay the operation of overcurrent protective devices in the event of a ground fault. Therefore, it is crucial to follow the NEC requirements for ground lug placement and grounding wire installation to ensure the safety and reliability of electrical systems. In summary, the NEC requires that the ground lug on duplex receptacles be located in the strap closest to the center of the receptacle, as specified in Section 406.6a. This requirement is intended to prevent excessive bending and potential damage to the grounding wire. Additionally, Section 406.6b mandates that the equipment grounding terminal be oriented in a way that protects the grounding wire from being pinched, punctured, or damaged by terminal screws or other surfaces. By adhering to these requirements, electricians and other qualified personnel can ensure the integrity of the grounding system and minimize the risk of electrical hazards. The grounding system plays a critical role in electrical safety, and proper installation practices are essential for protecting people and property from the dangers of electricity. Failing to properly ground electrical systems can have severe consequences. If a fault occurs, such as a live wire coming into contact with a metal enclosure, the absence of a proper ground connection can result in the enclosure becoming energized. This creates a significant shock hazard for anyone who comes into contact with the energized enclosure. Furthermore, without a low-impedance ground path, the fault current may not be high enough to trip the circuit breaker or blow the fuse, which means the dangerous condition could persist indefinitely. In addition to shock hazards, improper grounding can also increase the risk of fire. When a ground fault occurs, the fault current can flow through unintended paths such as metal conduits or building structures. This can cause excessive heating and potentially ignite combustible materials. A properly installed grounding system provides a dedicated low-impedance path for fault current, which helps to quickly trip the circuit breaker or blow the fuse, thereby minimizing the risk of fire. The NEC provides comprehensive guidelines for grounding and bonding electrical systems. These guidelines cover various aspects of grounding, including the size and type of grounding conductors, the methods for connecting grounding conductors to equipment and structures, and the requirements for grounding electrodes. Grounding electrodes are conductive rods, plates, or other devices that are buried in the earth and connected to the grounding system. They provide a connection to the earth, which helps to stabilize the voltage of the electrical system and provide a path for fault current to dissipate. The NEC specifies the types of grounding electrodes that are permitted, as well as the minimum size and installation requirements for each type. Common types of grounding electrodes include ground rods, ground plates, and metal underground water pipes. The selection of the appropriate grounding electrode depends on factors such as soil conditions, local regulations, and the size and type of electrical system. In addition to grounding electrodes, the NEC also addresses the importance of bonding. Bonding is the process of connecting all metal parts of an electrical system together to create a continuous electrical path. This includes metal conduits, enclosures, equipment frames, and other conductive components. Bonding helps to equalize the voltage potential between different metal parts, which reduces the risk of electric shock. The NEC specifies the methods for bonding metal parts, including the use of bonding jumpers and bonding screws. Bonding jumpers are short lengths of wire that are used to connect different metal parts together. Bonding screws are special screws that are designed to provide a reliable electrical connection between metal parts. Proper bonding is essential for ensuring the safety and reliability of electrical systems. The NEC also provides guidelines for grounding sensitive electronic equipment. Sensitive electronic equipment, such as computers and medical devices, can be susceptible to damage from voltage surges and electrical noise. Grounding these devices properly can help to protect them from these hazards. The NEC recommends using isolated grounding systems for sensitive electronic equipment. An isolated grounding system is a special type of grounding system that is designed to minimize electrical noise. It consists of a separate grounding conductor that is run directly from the equipment to the grounding electrode, without being connected to the building's main grounding system. This helps to prevent electrical noise from the building's electrical system from interfering with the operation of the sensitive electronic equipment. In addition to isolated grounding systems, the NEC also recommends using surge protective devices, or SPDs, to protect sensitive electronic equipment from voltage surges. SPD are devices that are designed to divert voltage surges away from the equipment, thereby protecting it from damage. SPD are typically installed at the service entrance of the building, as well as at individual equipment locations. The NEC provides guidelines for the selection and installation of SPD. The NEC is a complex and comprehensive document, and it is essential for electricians and other qualified personnel to have a thorough understanding of its requirements. The NEC is updated every 3 years, and it is important to stay up to date with the latest changes. Many jurisdictions require electricians to be licensed, and licensing typically involves passing an examination that covers the NEC. Continuing education courses are also available to help electricians stay current with the latest code changes and best practices. By following the NEC guidelines for grounding and bonding, electricians can ensure the safety and reliability of electrical systems. This helps to protect people and property from the dangers of electricity. Proper grounding and bonding are essential for minimizing the risk of electric shock, fire, and equipment damage. They also help to ensure the proper operation of overcurrent protective devices, such as circuit breakers and fuses. The NEC is a valuable resource for electricians and other qualified personnel, and it is important to consult it regularly to ensure compliance with the latest code requirements. In addition to the NEC, there are other standards and regulations that may apply to electrical installations. These may include local building codes, state electrical codes, and federal regulations. It is important to be aware of all applicable codes and regulations when designing and installing electrical systems. Compliance with these codes and regulations is essential for ensuring the safety and reliability of electrical installations. In conclusion, understanding and adhering to the NEC requirements for ground level placement on duplex receptacles, specifically sections 406.6 and 406.6b, is crucial for ensuring safe and compliant electrical installations. Proper grounding practices, as outlined in the NEC, are essential for protecting people and property from the hazards of electricity.